All right, this is the last section for differential equations unit, or the last section on differential equations. So this last topic is on slope fields. So we're going to be referring to this as slope fields, but you're also going to see term direction fields, and they refer to the same thing. So slope fields simply is a graphical approach to look at all the solutions of a differential equation. And slope fields, basically they consist of short line segments representing the slope or the steepness sketched over on at a lot of different points. Okay, and these line segments are the tangents to a family of solution curves for a differential equation at various points. The tangents show the direction at which the solution curves will follow, and slope fields are useful in sketching solution curves without having to solve a differential equation algebraically. Okay, so let's talk about the steps that we're going to follow to create these slope fields. So first is we want to identify the ordered pairs indicated on the graph. Okay, and we're going to see that below that on the graph. Where I'm going to have points that we're going to be focusing on. Next, we're going to plug in the ordered pairs in the differential equation to identify the slope. Okay, the third, we're going to sketch a short line segment representing the slope through that given point. And then we're going to repeat this for all the remaining ordered pairs. Okay, I have some additional notes here, but I'm going to come back to that after we do example 1A and B. Okay, so example 1, it says sketch a slope field for the differential equation at the indicated 8 points. So here we have the 8 points here, 1, 2, 3, 4, 5, 6, 7, 8. And I just went ahead and filled in the ordered pairs for x and y. So we're going to plug negative 1, 2 into this differential equation to find the derivative. And from there, we're going to sketch a line segment through that given point. So I just went ahead and filled out these ordered pairs that we'll be using, and for part B as well. So let's look at part A. Okay, so negative 1, 2 is this ordered pair up here. Okay, so we'll plug negative 1 in for x, plug 2 in for y. So negative 1 minus 4 will simply give us negative 5. So we just fill in negative 5. This is the slope at this point, negative 1, 2, according to this differential equation, x minus 2y. So negative 5 is a pretty steep negative slope. So we're going to put, through this point, we're going to just sketch an approximation of negative 5. So just have to make the negative slope relatively steep. Okay, we're not going to be expecting you to graph this exactly, but we're just going to be representing using, so we're just making a rough sketch for this slope field. All right, the next order pair, negative 1, 1. Negative 1, 1 is this order pair here. So we're going to plug negative 1 for x, 1 in for y. So we have negative 1 minus 2. Negative 1 minus 2 is simply negative 3. So let's fill in negative 3. And we'll make a slope, a short line segment representing negative 3. So still negative slope, but not as steep as negative 5. Okay, so maybe something like this. All right, let's plug negative 1 and 0 in for x and y. So negative 1 minus 0 is simply negative 1. Okay, so negative 1, I'll make a slope of negative 1 here. Next order pair, negative 1, so negative 1 in for x, negative 1 in for y, so negative 1 plus 2 is positive 1. So negative 1, negative 1. This order pair, I'll create a slope segment of positive 1. Okay, so we're going to fill in the rest of these points here. So plug in 1 and 2, so 1 minus 4 is negative 3. 1 minus 2 is negative 1. 1 minus 0 is 1. and then 1 minus positive 2, 1 minus negative 2. So 1 plus 2 is simply equal to 3. So we're just going to fill in. So at 1, 2, 1, 2, we're going to have a negative slope of 3. Okay. At 1, 1, we'll have negative slope of negative 1. At 1, 0, positive slope of 1. And at 1, negative 1, we'll have a positive slope of 3. Okay. So we're just making rough sketches based off of the slope that we find. Okay. So we do the same thing here. Plug the same order pair. So negative 1 in for x, 2 in for y. So 2 plus 1 is 3. 3 divided by 2 is 1.5, but I'll leave it as 3 halves. Okay. Plug negative 1 in for x. So we get 2 plus 1 is 3. 3 divided by 1 is positive 3. Plug negative 1 in for x, so 2 plus 1 divided by 0. Now, we can't have anything divided by 0, so we're not going to put a line segment there because the slope is undefined there. So I'll put a UND there. Plug negative 1 in for x, so 2 plus 1 is 3, divided by negative 1 is negative 3. Plug 1 in for x, so 2 minus 1 is 1, 1 divided by 2, 1 half. Okay. 2 minus 1 is 1, 1 divided by 1 is 1. 2 minus 1 is 1, 1 divided by 0, undefined. And 2 minus 1 is 1, 1 divided by negative 1 is negative 1. So I'm going to go down and fill in these slopes here. So at negative 1, 2, I'll have a slope of 1.5. Okay. At negative 1, 1, I'll have a slope of 3, so I'll make this steeper. Negative 1, 0, I'll leave this alone. There's no slope, undefined. Negative 1 is negative 3. So negative slope of negative 3. A slope of negative 3. 1, 2 is 1 half, so I'll make this a slope that is not as steep as 1, so okay, maybe something like that. At 1, 0, I'm sorry, at 1, 1, positive 1. At 1, 0, undefined. And finally, at 1, negative 1, we'll have a slope of negative 1. Okay. Okay, so let's talk about the slope fields here, or talk about what the differential equation and what the solution provides for us. We're going to see this on the next page, but we're going to use the differential equation to find the individual slope segments creating the slope field. So that's what we did just now, right? Where we used the differential equation, plugged the order pairs in, and we are able to find these individual slope segments. So for instance, something that is in the form of what we just saw, or maybe dy over dx equals x. Okay, anytime you see a differential, you know that's going to be your differential equation. Now, when we solve this differential equation, where we take the integral, right, where we separate the variables, take the integral, solve for y, when we look at the solution for this differential equation, right now we're not able to see this shape that is created from this slope field because we only have a couple of points, and this is just for demonstration of creating the slope field. But imagine all these short line segments over the course of a lot of different points. A shape is going to show up, and that shape is going to be very similar to the solution for this equation, for this differential equation. So let's say we find the differential equation of dy dx, the solution to be y equals x squared over 2 plus c. Now x squared over 2 is simply a variation of a parabola that's opening up. So we have all these different variations of this x squared over 2 if we just take a step back and look at the shape from this slope field. Okay, and we'll look at that on the next video when we look at the back page.